Good afternoon and welcome to today's Machine Design, EHS Today, and New Equipment Digest webcast. Our topic today is Risk Assessment Methods for Machine Safety and Cobots, sponsored by Schmersal. I'm Bob Vaver with Endeavor's Design and Engineering Group. Let's talk about how you can participate in today's presentation. If you have any technical difficulties during our session, simply type your issue into the Ask a Question box and a member of our team will assist you. You can also click on the question mark Help button in the upper right-hand corner of your screen. We also welcome your questions during our event today, and we'll get to as many of those as we can during the Q&A session that will follow the main presentation, so feel free to send in your questions at any time. To do so, simply type your question into the Ask a Question box and click on the Send button. If you'd like a copy of this presentation, please click on the Event Resources tab on the side of your screen to download the presentation. Also be aware that today's session is being recorded and will be available on the Machine Design, EHS Today, and New Equipment Digest websites within the next week. You'll be notified by email when the archive is available. Let's meet our speaker for today. Peter Rigakos is a licensed professional engineer. He received his bachelor's degree in electrical engineering from Saginaw Valley State University and an MBA from Purdue University. Peter started his career as an electrical engineer, designing and reviewing automated safety systems, primarily for automotive manufacturing facilities. Since that time, Peter has gained extensive knowledge in machine safety for various industries, allowing him to obtain his TUV functional engineering certification. So Peter, safety is an enormously important topic for our audience, particularly in an age of cobots. We're very interested in this presentation and we're looking forward to it.
Thank you, Bob. Thank you for the kind introduction, and thank you everybody for attending today. It's an honor to be here. Again, I'm Peter Rigakos. I'm here today to talk to you about risk assessment methods for machine safety and cobots. Okay, so before we get into this webinar, I wanted to share some background as to where this topic came from. So in our past webinar in April of 2021, we discussed what we thought are the 5 fundamental building blocks to create a machine safety mindset. So the five building blocks we discussed are shown on the slide, but after the last webinar, there was much more I could have spoken about each building block, but as you can imagine, time did not allow. So after that, I could not help to think that some people left saying, I wish he would have talked about risk assessment further or deeper, or any of the other building blocks for that matter. Well, that's what today's webinar is for, to understand the value and dive deeper into risk assessment to get closer to our ultimate goal of building our machine safety mindset. Now, keep in mind, today, the last webinar in April of 2021 is not a prerequisite for today's webinar. If you weren't there, totally fine. You'll be able to jump into this and understand it. Now, and if it sounds interesting, the last webinar, and you'd like to see it, throw something in the comments, and I'm sure we can send you a recorded version. But by no means does it mean that you'll be lost today by any chance. But during that last webinar, we concentrated a lot on the company standard as being the foundation of the building blocks. But risk assessment is close to or just as important. Risk assessment tells us much more about the risks associated with the machine, as it trains everyone to understand the machine better, and more importantly, to find the risks that are hiding from us. Right? So it's important to understand that. As an example, it's easy to look at a chop saw, right? We all know what a chop saw is. It's easy to look at that and determine why it's dangerous, right? But it's not always easy to understand all the features or hidden features that make a chop saw dangerous. And that's what we want to also determine when we do a risk assessment. So one story that always sticks out to me from my past while I worked in consulting and design was when I assisted in a project where there was an amputation on a piece of equipment that functioned like a press. Very similar to the picture you see on the screen, right? You can see this girl, she's putting a piece of equipment into a press-like system. When she pulls her hands out, hits reset, and the press functions. Now, I want the audience to remember this photo because it's going to come up later in the presentation, right? So that was about 15 years ago, and during those times when we got a call to come to look at an injury, typically those machines never really had proper safety devices, believe it or not. It was very common that they didn't have the right safety devices or use the right safety technologies. Now, however, this machine that I reviewed had safety light curtains that triggered the press to stop. and they were wired correctly to a safety relay. So I instantly thought it was odd that a machine with safety light currents could allow for an amputation, right? So the wiring was correct, the distance from the hazard looked about right. So the accident was not typical, right? Somebody took the time to add safety controls properly. So I started my investigation, and when I asked to have the machine cycle, I noticed that when I broke the light curtains, the machine completed its cycle and then stopped. So the engineer who designed the safety circuit portion did well. But if a risk assessment was done, I feel more questions would have been asked and the machine behaviors analyzed to provide a solution to prevent the press from completing its cycle after the beams were broken. A risk assessment could have prevented the amputation on a machine that gave the operator a false feeling of safety because light curtains were installed. So over my 15 years in safety and automation, I've noticed that the majority of people I meet with agree that safety is important. But when I ask them to perform a risk assessment, if they have performed a risk assessment, or even if they do risk assessments, the room always usually gets quiet. So the nice thing is, over the last 6 years, many know the term risk assessment, but still, the person that I'm talking to typically doesn't want to be the person to perform the risk assessment. You know, I don't know why, but I feel it's a fear of not knowing the machine, or the fact that there are so many others that work closely with the machine, or that they do not feel like they're the right person to do the risk assessment. At the end of the day, one person cannot do a risk assessment alone, right? And this is what we have to understand, right? It's kind of like building a house. I do not know many that can lay concrete, they can do framing, plumbing, electrical, roofing, etc. I'm sure some in this audience know someone like that, and I do, but it's very far and few between. But a risk assessment is the same, right? Multiple disciplines need to help each other and work together. Now, I mean, this sounds like a risk assessment for one machine might take 8 months, like building a new home, but we do not want it to take that long either, right? The key here, where I'm getting at, is that we need to understand the equipment and what it does. You know, like the example of the amputation, the effort was great. The technology was great, but the error came because the engineer did not understand the machine well and how it functioned. So continuing with who should do the risk assessment, right? I hear many times from my experience, you know, engineering should be doing this, right? But a study here on the screen here, a study was presented by Alan C. Ward and published in the American Society of Mechanical Engineering Journal, right? And you can read the quotes, but it comes down to engineers lack the tools and safety theory to understand how to identify hazards and risk. This was written in 1992, and I'm sure we'll all agree that was a long time ago. Unfortunately, I remember it like yesterday, but it was a long time ago. But I feel the same as today. You know, when I graduated from college in 2003 from electrical engineering, none of my courses discussed safety. I didn't learn it till I went into the workplace. I knew nothing of it, right? And and I think that's probably the case today. Not a lot of courses still talk about safety. So relying on these engineers to know safety is not correct, right? From their training at school, you know. And as explained in our previous webinar, we need to stop relying on what we think, what each engineer thinks is safe, right? And we need to determine a standard method to what is safe. You know, environmental health and safety engineers, you know, they rely on engineers to help implement the control measures needed. You know, but at the end of the day, both must work together with operators so we know what is needed to meet production while we keep everybody safe. So we've discussed why a risk assessment is not the task for one person, right? It possibly causes the fear of unknown. And that designers, engineers, maintenance can make things work, but they're not formally taught how to identify a hazard, outside of what they think is safe, which is inconsistent, right? But in the next slide, we will discuss the foundation that must work together to build the foundation for a successful risk assessment. So again, if we use the example story I discussed at the beginning of this presentation. So some of the things I left out of the story were that the engineer that designed the safety circuit was at the junior level. And when I asked, I said, hey, has a risk assessment been done? The engineer just stared at me, right? let alone didn't know what the term was, didn't know what a risk assessment was. So, but it was his idea to install safety light curtains. You know, he met with, I think, someone in sales, or he saw it in a catalog, and he saw safety light curtains. He said, hey, we can use these, right? So, and furthermore, the engineer used, you know, a circuit example from a catalog, bought all the right components, and had them installed per the catalog design. You know, and I thought that was smart of him, right? To find an example circuit. You know, it would have been nice if the example circuit was in a company standard, but regardless, an example was used, right? And so the engineer sourced some good information at least. Now, the missing steps were to simply understand the machine outside of the operation manual. So the first part of a risk assessment is to watch the machine in each mode and watch the operator interact with the machine. It's important to see how people interact. You know, so over my time, I found that having a conversation with multiple operators and a few maintenance people, it's the best way to get up to speed with the machine. The magic question, I call it, right? The magic question that I find that works for me to help me understand is, you know, I usually ask operators typically, you know, what do you hate about working with this machine? You know, sometimes I get responses from operators that are like, you know, it does not break down enough, so I can't get a break. Or maintenance will say, you know, it's always jamming and I can't get a break. But in all seriousness, this question helps anyone in EH&S, engineering, maintenance, understand the temptations to bypass. So now, if the machine is new, right, and it's being built by an OEM, the machine builders here today, take time to think if some of the tasks are realistic or it's something that you think you could see yourself being bypassed, right? A lot of times working for an integrator, you're asked to do things and you're saying, does this sound realistic? Are they going to have people bypass it? Because when we make it too safe or bulletproof, it causes bypassing. So we have to find that balance, right? So, you know, or, you know, again, for the machine builders, have you built a similar machine in the past, right? If yes, do you know what is currently being bypassed on the machine, right? So maybe it's something to investigate further for future design. Recently, I was visiting a machine, looking at a machine, and the parts were jamming. It's brand new. And supposedly this company has built many of them. And I was amazed to hear that they're already jamming. And I was there to provide a solution for operators not to get hurt while clearing jams. But the question was, why wasn't this brought back? It was a brand new machine. And have they seen this with other facilities in the past where they could have corrected it, right? So do your own homework. Talk to the right people who know the machine intimately. Also, about a year ago, I was doing a risk assessment on a basic machine. It was a mixer, basically mixed solution, nothing more than that. Like baking a cake when you have a mixer, same idea, but in an industrial establishment. So everything seemed straightforward. I asked my questions, took my pictures. I thought, yeah, this is an easy one. About to leave, and I said, no, do your due diligence, ask the operators just to be sure, all right? And the second operator I spoke with told me that, you know, I have to bypass this switch because the blades had to be in a certain way before they started. They had to be in a certain direction for some reason. And I would have never known that because I don't know the machine. And so once they told me that, he showed me a switch he bypasses, and these blades could function in full speed. Now, right away, you know, we're thinking, hey, we got to eliminate this bypass. We got to kill this bypass so they can't use it again. But no, we have to work with the operator to see how they can do their job. And in the end, what we did was we provided a two-hand control, and the operator could jog the blades while the system was open, put them in the right position, and then close it and it can run at full speed. So we made a good solution, but if I walked away and I didn't ask those questions, they would have continued to bypass. So from the people you spoke with, right, who do you think had more experience understanding the machine and how to get it working, right? So in my past, when I worked with an integrator, there were times we built machines and we would get called for intermittent faults, and we had to wait and see the fault happen. But sometimes there was an operator that could cause the fault. These operators were very difficult because every time I thought I had a solution, I didn't, because an operator quickly proved me wrong. However, those are the type of operators that you want in the room working with you. They know the machine intimately. They know it up close and personal and what they need to do to get it production. And those stories will help you design it better, right? EH&S. EH&S, environmental health and safety, they need to know such a wide area of safety, right? So from MSDS sheets to confined space to fall protection, sometimes security, a wide range of safety, right? So here we know machine guarding safety well, but as an EH&S, you have to know so many more parts and a part of the world of safety. But like the operators we discussed, which EH&S has an understanding of machine safety or can help us source the right information to get the right standards? Or which EH&S has the resources, maybe a third party or someone they use and talk to to understand more about machine safety? Where can we get this? Which person has that information we can use? Engineering, maintenance, or design. Did anyone design the machine in the facility, or is there someone in maintenance that has spent a lot of time understanding the machine to explain the different modes and what the machine needs, or how, the areas of the machine? Can they explain that? Who are these people that work with the machine more? Machine builders, right? I've been in their design, and usually the service people are different. They go out after the machine to fix things, right? And in the recent story I told you about this machine jamming with parts, there was a service person there from that company doing the odd things because it was recently installed. And I talked to them. I said, hey, do you service a lot of these machines? And he said, yeah, I travel the country and I service these machines. And although I didn't say it, but I was surprised to hear that no one had talked to him. And although I did say, is this jam common? He said, very common, and he kind of explained why. But now, maybe it couldn't have been eliminated. Maybe they did talk to it. But I was very surprised to hear that he knew of this and maybe didn't bring it back to the engineers to say, hey, let's make a better design for safety and so on and so forth. So are we talking to those service people that are out there and see this problem? Are they reporting back? Or have they reported it back so much no one listens and we just said, I've told them 100 times and they don't listen, right? Who knows? So part of the risk assessment is not only identifying hazards and risks associated with those hazards, right? I find it really annoying when you see a risk assessment done and they just tell you that here's a hazard, there's a hazard, but they don't tell you the solution, right? So we have to apply solutions to mitigate these risks. So what technologies or redesign will we use for hazard identification? And I kind of equate it. It's kind of an example where if I had a leak in my house and I called a plumber and they just told me that there was a leak and what it was doing, but they never told me a solution, I always find it amazing that some risk assessments won't have solutions attached to them because it's a huge part of solving it. And not only putting something there, but also making it correct for everybody, maintenance, operators, and so on and so forth, right? And again, this applies to assembling the right team. A large part of the discussion you're going to have with your team is what technology will we use to mitigate the risk, right? So I will admit, as a safety professional, we can produce some solutions and fail to ask if the machine can even handle the solution. So this is why we need operators in the machine, like we were talking about, the design, the engineers, and the maintenance in the room to tell us if the solution we're presenting is even possible because they know the machine much better than we do. Recently, a few months ago, I test drove a car with my family. Believe it or not, I know they're hard to find these days, but we were able to test drive a car, and while all 5 of us we took the car for a test drive, I was driving and I made the comment that the car was a bit sluggish and slow. My 10-year-old son, he's always thinking of solutions, an engineer at heart, he suggested that we put a supercharger as an add-on to the engine to soup it up. I'm getting older using these words, and I was pretty amazed. I said, yeah, not a bad idea, but I'm not sure if that would work or even look good on a minivan, right? Do you want to put a supercharger on a minivan? Would it work? Would it break it? I don't know. But that's why we need engineering and maintenance in the room to be sure the solution is even possible, or an operator to let us know that it might slow their job down, or it might cause, production failures. And when we know that you're causing a slowdown or a production failure, you're tempting people to bypass, right? And I get safety is more important, but we have to balance production and safety so we don't get those bypasses in check. Now, the team you're assembling, okay, they may not have all the knowledge needed. So, is your team, are they limited in a portion of the review? For example, can someone on the team understand safety circuits, the middle drawing there? Or, for performance levels for either controls, hydraulics, and pneumatics. And we look at the top drawing, that's pneumatics. The middle is safety controls. And the last is stop time calculation and stop time measurement. Do we have people in our facility that can do those, review them, right? And many times we see that a mechanical portion of the risk assessment, it can be done internally, determining the hazards, where are these hazards, and so on and so forth. But many risk assessments, they fail to review the controls, hydraulics, and pneumatics. And that's a big part of the risk assessment. We can determine the the chop saw that's in front of us, and we can determine that, hey, it can chop, but are we reviewing what controls are the hidden hazards, right? We want to make sure that we're reviewing that as well. We also see a lot that machine builders, when they're building a machine for an end user, they need a signed document stating that the machine meets a particular level of safety, right? Now, the machine builder, they may have that, but some, they don't have a TUV person on staff, or they just simply don't feel comfortable signing such documents, right? So are we getting those from our machine builders? Do the machine builders need that kind of information? So this slide, it follows the last slide closely. Basically, it's okay not to have all the expertise in-house, right? Or the comfort signing documents. And therefore, you must determine which partners you want to work with. With how can they provide the documentation you need for the various portions of the machines. And a lot of times, I don't know, I've never heard of a company saying, hey, we'll do a risk assessment, but it's got to be all of it. We have to do all of it from start to finish. We won't do portions. I haven't heard of that. And, and if you feel comfortable doing that, the mechanical portion, and you say, hey, the controls, we're not comfortable at this point, we're going to have a third party do that, and we'll learn it over time. But there are third parties, but they need to be done. So there's no problem in doing a partial risk assessment on the mechanical, but having a third party complete the parts you're not strong at. You don't have the expertise in-house yet. And this, again, there's the same images, for example, even the stop time. Have we done a calculation? And a calculation is one thing, but in the end, we need to do a measurement. We have to measure the stop time. Do you have a measurement tool? There are third-party companies that have these tools and can help. Okay, so now we've established the background work that needs to be done to build the foundation to perform this risk assessment, okay? We've built that. We understand we're building our team. But now, within this presentation, we're going to start the act of a risk assessment. We're going to talk more about risk assessment itself on the steps. So again, we've talked to the right people. We understand the machine. We chose the right team. We understand our weaknesses, right? Where are our partners? Which weaknesses are we not going to do at this time? But we need to determine how we will identify hazards and risks. That's an important part. So on the screen, there's some ANSI and ISO standards. Some, not all, which discuss hazard identification and methods for quantifying the risk associated with the hazards. And I'll explain what the quantifying part is. In the next couple slides, you'll see that. But these will help you identify what a risk is and then how to quantify. And again, I'll get to that. So it doesn't matter which standard you choose, right? You choose one of these and you use it company-wide and stay consistent. Risk assessment is subjective, and you'll see how and why in the coming slides. As much as we can standardize as possible, that's the best, because we keep it consistent amongst all of our facilities. Now, if you have multiple facilities across the country, then it's even better to do that. If you're a machine builder and you use one system, the people that buy from you are relying on the machine builders to know these systems, because not everyone has it. They're relying to understand what system are you using, how are you determining your hazards, and how are you quantifying your risk. And they might lean on you, right, as a machine builder. So these images on the slide, they come from ISO 12100, and that's a standard that I showed in the previous slide, and they're from Annex B. And Annex B, they provide 10 hazards we should concentrate on when identifying risk. Now, there's only 8 shown here. I couldn't fit any more on the slide. But they talk about these 10 hazards that you should quantify, you should understand and know. You can see there's a crushing hazard, an electrical hazard, an entanglement hazard. Again, they get much deeper than this. Now, we will not discuss these in detail today, right? This is a webinar or even a training on its own, but this is where your company training should focus and come in place to train your team to look for hazards, right? And in the last webinar, we talked about having a training just dedicated to this, about teaching people to identify hazards. Now, like we said, the chop saw, it's easy to find, but what are the hidden ones? And this is where, again, in that first webinar, we talked about the apprenticeship program. Basically, you put someone in training, but also you send them out to do risk assessment with someone that's versed in the system of finding hazards. And when they meet a certain a certain number of risk assessment or hours, then they can do them on their own. Because again, we want to be able to find the hidden hazards, and that takes some training, right? So identifying these hazards and picking them and showing these are hazards, again, we're standardizing on that, and it's helpful, but we have to have the keen safety eye to detect them as well. So once we've determined a hazard, we say, hey, there's an entanglement, there's a hazard there. Now we can quantify the risk associated with the hazard. So I said I'd get to this quantifying. So there's many ways to classify a risk. And each standard we discussed in the previous slide, it helps with guidance to create this quantitative method I keep talking about. But here on the slide, we show one example using what's called the hazard rating number, or the HRN method. Okay, this was developed by a gentleman of the name of Chris Steele. It's not a method we've developed. This is a common known method in the world of risk assessment. And this helps us quantify the risk, right? But once again, it's an example of one method of the quantifiable part, since there's many standards you showed in the previous slide, right? But the goal is to choose one and stay consistent. So you got to choose this quantifiable method and then just stay standard on it. And again, I want to keep saying that this is not the only one out there. So we're going to use an example now, the same thing. We'll use the example of the amputation story from the beginning of the presentation. Now, I asked you to remember that picture. I'm not sure if it's gone, but I'll explain it again. There was a girl placing her hand in a part in a system there, and there was a press-like system that came up and down, and when she pulled her hands out, she would hit reset, and the system would go down and punch the part and performing the task it was performing, right? So before, though, we start this, every risk assessment, if you're doing an existing machine, now for machine builders, this wouldn't be the case, but if you're doing an existing machine, and just like the story I told, it had light curtains, we want to remove those light curtains. We don't remove them physically, you're not taking them off, but in your mind, remove them. And this is why we're quantifying the risk without any safety on it. We have to see how dangerous it is, right? And I'll explain it later, but we're removing those light curtains in our brain, and we're doing the risk that way. And that's, we'll do this together today, right? So now we'll look at that hazard. And so the first column, and then now you have your team in the room, the people we talked with, you're looking at the hazard you've found, and you're looking at the likelihood of occurrence, okay? And so the likelihood of occurrence, now, is it likely to be expected? I picked likely to be expected if I was doing the risk assessment before the accident or even after to know exactly. Now, there's a lot of people here maybe said, well, hold on, like who's gonna put their hand there and press reset and get it amputated, right? And yeah, and there's always someone in the room that says that from my experience. People instantly think that it's, I put my hand there and then I hit it and I'm purposely getting hurt. And I don't think a lot of people do that. I've heard of stories that they tried and so on and so forth. But we can't look at it like that. We want to put ourselves in the mindset of this person, it's more of a reactionary. It's a reaction and they got hurt. And so in this, again, this story, what ended up happening was, if the part went in and it went in on a little bit of an angle and it wasn't placed correctly, and you hit reset, it would basically potentially break a die, I believe, but it stopped production. And that person did not want to stop production, embarrassing or for whatever reason. So what happened was when they put it on an angle, they hit reset, they saw it and they reached their hand. The reaction was to reach their hand and put it correctly in that system, and that's when the amputation happened. So my point in telling you this, put your mind in a system like that. It's a reaction. It's not necessarily where they're trying to hurt themselves. And this column starts a lot of arguments with people in the room, or debates, not say arguments, but debates or discussions. And it's important to have odd people because sometimes you have to take a vote. So, if you don't want to tie, so you want an odd people number in the room, right? So for me, again, if I was doing this, I would have labeled that as a likely to be expected. Some may have done certain. Some may have done possible but not surprised, right? So it changes the number. So that's a 10. Frequency of exposure. Now, many standards will issue, I've seen some say, anything under once every 15 minutes is high. But your company standard can issue what constant is. You might say that's, for an R&D facility, constant might be different for a production facility because things are happening faster. So what's your constant? You can outline that. Degree of possible harm. So sorry, frequency I picked constantly because that was happening every 2 minutes, I believe it was. They were cycling every 2 minutes. So that for me was constantly happening. And that was 5 days a week, 8 hours a day, maybe even 2 shifts. So possible degree of harm, possible harm, that was a loss of 2 limbs. If his reaction went in and he had 2 hands there, might have done amputation to 2. So I did 10, an 8. You might have done a 4. Now, and the number of persons at risk, that's an easy one. That's 1 or 2, so that one shouldn't cause any problems. Now, so if we take 10, we take 5, we take 8 and 1, we multiply them, we get 400. Okay, great. But what does 400 mean? So what is 400? So now we've quantified the hazard associated with the example we showed in the beginning. So 400, you can see in this slide here, it falls under very high, which is obviously high and needs to be corrected. Okay. So now, depending on what you chose, I know we didn't rush through that, but I'm not sure if you followed along with the example and picked what you did. But depending on what you chose, there's a very good chance you would have been from high to unacceptable. Okay. And so now people say, well, it's very high or high. There really isn't a difference. If it's from high to unacceptable, that has to be changed. It's something of concern, and even significant is too. So depending on what numbers you choose, you will get in there on that hazard if you knew all the details and so on and so forth. So here's a photo again. We know we have a very high, and we've determined that's a very high risk. But now the most important question comes: how do we solve it? Right? And this comes again to that plumber example. We determine that it's high, but how do we solve it? Now this example has light currents, right? And the engineer said, hey, let's use light currents for this, right? But what solution do we use to mitigate the risk for this very high? Do we use guarding, controls, interlock, scanners? Do we redesign it, administrative controls? And again, for machine builders here, that's a very strong point. You have a lot, because you're building a machine. You have a lot of things to change, right? But what do we use, right? Now, if the guarding you had in place works great, that's awesome, right? So in this case, they had a light curtain in place. Awesome. Light curtain's great. However, if they're putting a light curtain on, you have to determine what performance level these light curtains have to be installed to. So you have a light curtain, it solves it, but you have to determine, okay, how am I reviewing the controls drawings to determine that I indeed need a performance level D or an E? And that comes from a standard where we look at severity, frequency, and possibility. It's very similar to another risk assessment, and you come up with a letter from A to D, and that tells you how you have to have it designed. Now, is this our uncomfortable part where we say, you know what, we're not ready for this, we're going to give our partner. We want our partner to look at all these drawings to make sure that they meet performance level D from our risk assessment, right? That's something you can do and look at in that example. Or now, do we add other controls to it? So it's important to understand this portion, right, and how we're going to accomplish that. Now, again, the amputation example, so if the junior engineer, when he presented the safety light curtain as a solution to knowledgeable risk assessment team, so let's reverse the story. Now we have this team, and the junior engineer came and said, hey, I have a safety light curtain that we can use. There's a much better chance that that knowledgeable assembled team of operators, EH&S, maintenance, or design engineers, they would have suggested that the only way a safety light curtain can be used is if there's a way to stop the press from continuing its cycle after the beams were broken, right? Because they know the machine intimately. So the light curtain was a great solution. Even if we had a third-party company review to say, yeah, it is performance level D, we still need to understand the machine that it needed a break, right? So if nobody in that room knew, like there's a technology exists like a break, that junior engineer would have had more information knowing about the machine, and possibly would have extended his research to find out that the brake, there's a press brake that could have been purchased, or some sort of brake that would have stopped the press and preventing the amputation. Now, in the end, fortunately, we solved this. We provided the brake they could use, and they installed it on many pieces of equipment, but it came at the cost of an amputation, right? So again, we solved it and such, but it did come at the amputation. So we want to get this done before. So again, assemble the right team to provide the right solutions for everyone. So after completing all the hazards in the machine, right, using this HRN or any other method, you could have got from 10 to over 100 scores, right? So you might have, depends, it might be a small machine, it might be a large machine. So you might have 10 or over 100, who knows, right? But the goal at this point is prioritize the risk, which gets updated first, right? So for example, your company may say, okay, they may choose to prioritize all the high to unacceptable before the very low to significant. So this will make the task of upgrading more manageable, right? And again, these higher priorities, they're all going to fall in there. So when it's subjective, I'm hoping that we're going to pick something close enough that if my very high and your high, doesn't matter because now it's in the high priority. It's going to get fixed just as fast as a very high or an extreme. So we're hoping that range, right? And now, and machine builders here, you have a very good chance to, again, design out or add certain features or talk with the company you're building the machine for to say, hey, we have an unacceptable hazard here. Maybe we want to talk about something different to prevent the possible hazard or injuries. Okay, so here is a flow chart, and I took this from the ISO 12100. And ISO 12100 again is that standard that we talked about that shares and helps us with risk assessment. And basically it's simplified, okay? But if we take this standard and we use that flow chart, if we look at the first one, the limits of the machine. So they basically say, understand the machine, understand its modes, and then go on right there. But we're taking it further, and we added a lot of foundation to the machine. We had a lot of foundation in the sense of, building the team, understanding the machine, get the right questions, have multiple people doing the review. Do we have partners? Just reminding you of that. That is that portion. That's a very important part, so we don't miss the hidden hazards. Hazard identification, we talked about that. Have a training program to identify hazards, or even that apprenticeship program. That you're training people in your facility to do risk assessment. Risk estimation, that's our quantifiable method. Again, in this example, we use what's called the HRN method, right? The hazard rating number developed by Chris Steele. So have that method prepared and ready. And risk evaluation, our solutions. What technologies are we going to use? Now, technically at this point, when you've done those four, it's actually called a risk analysis. We haven't done technically a risk assessment, right? And why? So a lot of times we use the term risk assessment loosely, right? And a risk assessment actually goes and does the HRN one more time over, but with the guarding on. So I know I told you got to remove all the guards and the light curtains and do it. We quantified it, but now we do our HRN with the guarding on. And if it comes down from that very high to negligible or significantly low, then we know that we've accomplished it. So now we have something in place. We've done our controls, we've reviewed all of it, and now we've done our risk assessment. So we have to do it once time over to be sure that we're covering our task. Because if you put a form of guarding there, and then you do the risk assessment again with the guarding and it comes out high, then we got to go redesign it. And we got to say, okay, that's not good enough. So technically, when we do it a second time, that's now called a full risk assessment. Okay, so now we've built our foundation. Okay, we've set up our methods for risk assessment, but where do cobots come into place, right? So where cobots? Now we want to talk about cobots, and now for the people here that don't know, cobot is a short term for collaborative robots, and again, for the people that don't know, a collaborative robot is basically a robot that works amongst people. It's like a safe robot. If you touch it, it stops. It moves at a slow speed, and again, it can be amongst people. So a traditional robot, you have to put it in a cage. It has to have safeties. You can't get near it because if it hits you, it'd be really bad. But these robots, they can sense, they can, once they touch, they stop, they move slow, they're light, they don't have heavy end effectors that can push people. So they're essentially like a safe robot. And that's what it is in a nutshell. Okay, so before we go on to talk about collaborative robots, we wanted to ask the audience today. We wanted to push this poll question. We're going to push a poll question to you, and go ahead, please, and push that poll question. But are risk assessments required for collaborative robots? Again, very simple yes or no. And I will give you guys some time to start answering that. So again, just a yes or no question. I'll take a sip of water here to give you some peace and quiet. All right, we're at 20 seconds. Keep going, guys. You're doing good. Okay, we can end the poll now. Okay, so do we have the poll? I believe we have the poll. Yeah, we have the poll results. Can we send the poll results to the audience, please? Okay, so I am not sure if we can see them. However, yes, we can. Awesome. So we can see that 97% of people said yes, and 2.4 said no. So fantastic work, guys. We got the right crowd. Thank you for taking part in that poll. I tried to edge you a little bit by saying it's safe and that. However, so whoever got the answer is yes, they do need a risk assessment. So great work for the audience. Risk assessments need to be done. And on the screen here, you'll see that there's basically from the Type C collaborative robot standard that it says yes, risk assessments need to be done. And I will explain Type C, what a Type C standard is in the next slide. But yes, risk assessments need to be done on collaborative robots. And the reason why we wanted to bring this up is that many of us hear from time to time that, hey, it's a collaborative robot. It's safe, right? We don't need to do risk assessment on that part of our cell. And there's a common misconception simply because it touches a person, it stops, but it still requires a risk assessment. So we hear it time and time again that it doesn't. However, they do need to be have a risk assessment done. Quickly, just between Type A, B, and C, a Type A standard is basically a standard that is very general. So our Type A, like determining hazards, we can determine these hazards for anything. We can do it for a robot. We could do it for a conveyor belt, anything, very general. Type B is like a performance level, right? We talked about performance level. It's controls, but it's very simple. 2 controls, and it can be on any system. And a Type C is like what we said, collaborative robots are robots, right? So these have their own specific things that need to be done in these cells. So a cobot may stop once it touches a person, but what job is the cobot performing? So the end effector of a robot, it can perform many tasks, right? So for example, the end effector, it may use suction cups to pick and place products, and that's what we see doing a lot. It could use a knife to open boxes, right? It may use a drill to clean burrs off a part. Many different applications as shown on the slide. But I'm sure everyone here will agree that a hazard associated with a suction cup is a lot less than a knife cutting boxes or spinning a drill bit. So the point is, all cobot applications are case by case, right? They need to be risk assessed. We need to know what's on that effector and what the job is, what job it's performing. So, and we can use that by using all of our different standards. Now, also too, Type C standards have specific things that you might have to look for, right? So, for example, in the Type C cobot standard, there's something that's called transient contact or quasi-static contact. And that requires the measurement of force between the operator and a part of the robot or fixed structure that is clamped. So this is, are we doing this as part of when we enter a collaborative robot? Are we measuring the force? There's a measurement tool you use to determine the force. So it does stop, but we got to measure to see if the force is too much, right? And that's part of the standard. Do we know about this? Are we doing that? Is it part of our assessments? So, you know, a risk assessment, it's always going to follow the basics we discussed at the beginning of this presentation, right? So we're always going to follow that, but we need to be sure we're catching all the unique items from Type C, kind of like the last slide I just talked about. We want to be sure we're discussing all those little things that in the Type C standards, right? So just think of it as an add-on to what you already need to accomplish, right, when completing a risk assessment. So how can we accomplish all of this? Since, you know, there are hazards you must identify, but also answer questions if a Type C standard exists, right? What we can recommend. So how do we do this when we have all these Type C standards? And it kind of gets confusing, but what we recommend is breaking up the risk assessment into a task-based risk assessment and a machine-based risk assessment. So the task-based risk assessment, it looks at all the hazards associated with the task completed by operators, maintenance, setup, cleaning, etc. Okay? And machine-based risk assessments, it's like a catch-all that continues to use a quantifiable method, right? The HRN we talked about, but asks questions to be sure we're reviewing items from other Type C standards, such as like cobots and robots and so on and so forth. So these questions, we want to put them into sections in your risk assessment from all the Type C standards. And if they do not apply, let's say you're reviewing a cell that doesn't have a cobot, well, then that section you have for cobots is it's not applicable, right? And that's okay. So therefore, you have a standard type risk assessment you're doing everywhere, keeping it standard for all the types of machines in your operation. And now if you add a cobot later, you can reopen that risk assessment and answer the questions for a cobot or a robot or anything with a type C. So now, like, to end this, I'm sure, many of you are thinking, like, I understand the process you showed, it's simple, like I can get through the quantifiable methods, but where do I start? What quantifiable method do I choose? Do I need a template, a particular template of software? Or how do I know if the machine's outside of cobots? Like, how do I know there's Type C standards in my facility, or even if I'm building them, right? So we think a great method to start is first, determine your quantifiable method you want to use for the risk assessments, right? Again, we showed the HRN method. Now, the second, determine the Type C standards you use in your facility. So find the machines that you use that have a Type C standards. From there, you can build a spreadsheet, you can buy a software, and you can introduce your quantifiable method and add the sections to answer those Type C questions in the machine-based section of your risk assessment, right? Now, again, you might say, okay, that sounds okay, but how do I start? Like, where, just remember, there are third-party companies that can get you off started and perform this work. They can do the work for you, but they can also get you started. They can help you choose a quantifiable method. They can build a standard for you. They can build that template for you, or introduce a software to you that you can use to build that for your facility, your complex, your business. So again, I hope this helped. It's 45 minutes is tough to fit in risk assessment and cobots, but I hope I answered some questions, and I will pass this off now to ask any questions anyone has. Thank you, everybody.
Great. Thanks, Peter. Great presentation. A lot of great information there, and we've got a lot of great questions coming from the audience, so we'll get to those in just a second. If you'd like to submit a question, type it into the Ask a Question box and hit the Send button. And also, please take a moment to complete our feedback form, which is located at the bottom of your screen. A lot of questions. Risk assessment's a huge topic for this audience, and we'll start with this one. Shouldn't the risk assessments be generated at the design level of the machine in order to design out as many risks as possible?
Yeah, that's a very good point. That we always say it, and my whole time in safety, which has been a long time, it always has to be at the front end of the machine, a part of the building, even when it's on paper. That is the best way to do it. But realistically, there are a lot of facilities that have machines that are legacy that wasn't popular when they were built. So we do them when they're, we're retrofitting them. However, the machine builders in the room, it should be part of the beginning steps of with your customer and working with it and talking about a risk assessment. So yes, I fully agree with you, but if there's legacy equipment, it changes. Thank you for the question.
And let's follow up with a kind of a related question to that. If the machine's still under warranty, would you consider making changes to it in its machine guards with the involvement of the manufacturer so as not to void any warranty?
Yes, of course. I would, that's a great question. I would basically say, hey, risk assessment was done. We have to follow a risk assessment because the standards are, they're important to follow, and they're harmonized for everybody to use. And so I would bring that back to the manufacturer and say, hey, look, we don't want to avoid the warranty, but we have to upgrade this for safety. And so there might be some back and forth, but I think that you took the onus to do the risk assessment and do that, and to work together to upgrade it. I think you'll be surprised at how much you can get done while keeping everybody safe. So I would agree. Yes.
This is a really interesting question because I think it cuts at some of the things we see in manufacturing on a number of sectors. In picking granularity for a diverse risk assessment team, do you pick operators from different shifts? Do you find that the night shifts makes different operation and fixing decisions because qualified maintenance people are not available?
Yeah, that's a good one. I would for sure pick from different shifts, and what I've done too, and I do quite a bit of my past life, I would ask to find out the maintenance of, say, hey, which operators do you really work with on this machine, or which one come to you a lot and say, hey, this needs to be corrected. And so I kind of try to fish out who's the operator that's bothering them or coming to them a lot, or I try to fish that out, and they might be from different shifts. And they might be. So I will do at least 2 shifts if you can do that, right? You're there at one point of the day, so it's difficult. But I would try to spread my day where I was at both lunches. So the lunch in the morning and then the lunch in the afternoon, and that's an 8-hour separation. And I would talk to two people and to see, and then also if there's a maintenance person that says, hey, this person's always coming to me and always asking this, that person will tell you the ins and outs of everything because they want it fixed, right? So yes, a very good way to do that and a great way. And again, you're not doing it maliciously. You're not doing it to catch anybody. You're doing it to really work with production because production is very important and it will breed bypass if you don't help them.
And I just add operational assessment, not just risk assessment, is something that you see a great disparity of between shifts. Sometimes the night shift is more efficient and more resourceful in solving their own problems for the very reason that this question stated, that you don't have necessarily everybody watching or available at that hour to help them out.
Yeah, I would agree. That's very true. When you don't have the resources, you come up with things and you make it best. Yep. I would agree.
Yeah, you want to make sure that, particularly for risk assessment, they're making the safe decisions, not just the creative ones. Here's another question. How do you calibrate the likelihood or frequency of exposure? Is this based on the company's safety criteria, or is it machine application dependent? And are there guiding standards for setting these parameters?
Yeah, there are some standards where they help you. They'll tell you what the frequency of exposure is. And I've seen a lot of times people use once every 15 minutes is high, constantly, right? But now it changes where you have some facilities where they don't use the machine a lot. So if you were to do a risk assessment, the frequency of exposure is always going to be low and resulting in a very low, insignificant number. But it's a chop saw or something. So what happens is the EH&S tends to feel uncomfortable to say, hey, this is low and I don't have to put anything on it, but I want people safe. So what it is in some places I've seen is that they'll do more of a worst case type frequency of exposure simply because of their facility not using it. They'll change that value to help increase the number so they can add more guarding to it, right? So again, you want to do it ethically with the frequency of exposure so your quantifiable method comes out correct. But you may want to look at that as a company-wide and say, okay, we're going to adjust the frequency of exposure to, we're constantly producing is one thing. You can follow the standards that these standards offer as suggestions. But if it's not producing as fast, and again, like I said, the R&D facilities, then you may want to adjust that. And if you're adjusting it to something lower, where it's more worst case, then at that point, the values will come out higher, and it would help with your justification for that, if that makes sense.
And on the subject of standards, we had a question. On slide 16, what standard details that risk quantification?
Standard details, risk quantification. So on slide 16, I'm looking at that now. Let me just go back to it. Okay, here we go. That's 14, 16. Okay, can you repeat the question? Sorry.
Sure. What standard details the risk quantification on this slide?
Standard details. So the standard details of each one. So we would take, basically your negligible, and this is basically your score of your likelihood, your frequency of exposure, and so on and so forth. And when you come up with that number, you will have, it will fall into one of these boxes. And once it falls into one of these boxes, we know this detail. But that is a high. Where that has to be, it all depends on your solution now of how are you going to solve it? What guarding are you going to put that gets you away? And when you do your risk assessment with the guarding on, then that will drop it down to the negligible, and hopefully it will. And if it doesn't, then we got to think of something else. But I'm not sure if I answered that question clearly.
Okay. Here's another interesting one, because we talked about both risk assessment and cobots. Does the end effector and the parts that a cobot carries enter into the huge safety risk? If a robot hits a person with its own arm, that may be fine, but if the part in the end effector is such that the part could impale a person, how does that get handled within the cobot world?
Yeah, and this is why. And so that's the question. So if you do, let's say it is a knife and you get cut, well, does the end effector, when it touches you, does it stop? No. So now, should we be using a collaborative robot for this application? That's what that comes down to. So how do we put a piece of guarding around the end effector where you can't get to the knife? Can we add guarding? Can we add some sort of technology where you can't approach the knife. And that's that. So a good question, and that comes where that team of room, we need a good solution to come up with that. Because again, just because it's a cobot, it doesn't mean that that knife won't cut you, because that's not part of it.
Yeah. Another question, I'll read it from one of the audience members. I was under the understanding that a Type B standard applies to all machines. A Type C standard has usually been generated by a specific industry association, for example, and these standards supersede a Type B standard for that specific piece of equipment. Is that understanding correct?
That is correct, yes. Type C will always supersede, but you'll see that in these Type C standards, it'll say when it comes to controls, for example, it'll say, please refer to ISO 13849, and that's a Type B standard for performance levels I discussed. Or if it says, hey, review some of the guarding, it may refer to ISO 12100, which is a Type A. But yes, your answer, you're 100% correct in your understanding that a Type C will supersede a Type B and A, and a Type B will supersede an A.
Another question. A viewer says, I didn't see validation in the presentation. Is that one of the most important parts of the process?
Yeah, validation is important. It's actually a part, if we go to our slides here, this building blocks, these are the ones we talked about in April of 2021 as our whole safety mindset. And the top one is validation, and that falls outside of risk assessment. So when you build the machine and you have it installed, you're supposed to validate it now. So it doesn't fall within risk assessment. Your risk assessment is like the first step you've done. And then once it's built and ready, then someone goes and validates and confirms that it's actually installed correctly. And a lot of that is done because of, I would say there's many reasons, but one that sticks out is human error. You know, we had someone install the wrong input somewhere, and it could create a problem. So it's outside of risk assessment, but a very, very important part that I think we don't do enough of, and I bring it up a lot, and it's a very important part of safety.
We got time for a couple more questions. Here's one. If we have a third-party company reviewing the controls drawings for us, do they need to visit our facility, or can it be done remotely?
Yeah, it can be done remotely, a lot of it. So, I mean, in my past life, when there was a huge, large projects, we split up mechanical and electrical people, and I'm on the electrical side. And so there was a project for 1 year. I never went to the facility. I reviewed all the controls in-house, and I did them. And again, sometimes you need a mechanical person to say, okay, what is this thing doing? You communicate, but they can do it to a point. They can do it to a point where they're away and they can review the controls and tell you. But there's going to be a lot of conversations over the phone. Like, you know, when I've done it recently about a year ago, where you look at the control drawings and you're like, something I don't understand. But when you talk to the end user, they'll walk you through it and say, well, I don't see this and what's happening. And that's it. So yes, the answer is a good chunk could be done remotely. Yes.
I think we touched on this one, but is the machine builder required to do risk assessment when we purchase the machine?
Yeah, that's a question. So here in our region, North America, it's not a requirement for the machine builders. Now, if you look at the robot standard, ANSI RIA 1506, and I'm pretty sure this is the case, where the standard really calls out that risk assessments must be done. And so if we look at Europe, it's the machine builder's responsibility to do a risk assessment and complete it and provide a safe machine. But on our side of the pond, it's actually the end user's responsibility. But going back to that robot standard, they have flipped their view, and they're saying now, no, it's the machine builder's responsibility to do a risk assessment, provide a safe machine. So I don't know if that means we're going to start changing our outlook on machine builders providing risk assessments and a safe machine, but it's done on the other side of the pond in Europe for the CE. So I'd like to see that. Again, I'm a little biased. You know, I'm on the safety side. I love safety. So I think I'd like to see it that way, but at this time, they're not required from how I understand it.
Very good. Well, that's about all the time we have today. If we didn't get to your question in the presentation, we will be getting back to you via email. I want to thank Peter for a great presentation, great involvement from our audience today. So on behalf of Machine Design, EHS Today, and New Equipment Digest, I'd like to thank Schmersal for sponsoring today's event. And of course, thanks to all of you for joining us. Have a great rest of your day, and it goes without saying, stay safe out there.
Thank you, everybody.